Hey, welcome back to Fat Mama Physics. In this video, we're going to do more multiplying and dividing polynomials by a constant, but in this one, we are going to focus on division. So, in the last video, we emphasized the fact that if you're multiplying by a number, or a polynomial by a number, the number treats only the coefficients in the polynomial, or in each term. It does nothing to the variables. The variables stay the way they are. So in division, that's going to be the same as well. But all we're just doing is dividing, and that's the only difference. So let's take a look at what that means. Here I have an example. I am dividing everything here I have on the top by whatever's on the bottom. So this kind of looks like 4s squared minus 8 and in brackets divided by 4. I want you to be very familiar with this form of writing that. Because this, writing it as a fraction is such a powerful tool that you can easily see what things can cancel out, what needs to happen first, what needs to happen second. As you move into later forms of math, you will rarely see this format. Okay? So something to keep in mind. So let's go ahead, and what I'm going to do is we're going to use distributive property in which the 4 needs to divide into here and needs to divide into the 8. So if we rewrite that out, it's going to look like this. 4s squared divided by 4 minus 8 over 4. And notice I am going to be writing all of these division sentences like the form that you're seeing as in the fraction. Because now we can see which things are capable of which we can cancel out. So here we have the 4s and the 4s, the 8s and the 4s. These are all your numbers, which will affect one another while the others will not. So first of all, 4 divided by 4 is going to give us 1. We leave the variable as is, s to the power of 2, minus 8 divided by 4, that's just going to give us 2. And if we want to write it out neatly, this is going to look like s squared minus 2. That's it. Simple as that. Why won't you give example B a try? So good time to pause the video. And this one is a little trickier because you got to deal with negative signs. So for example, in the first one, you have negative 6x squared over 3, in which I'm just going to write that first and write in that negative and x squared there. Okay, then we have plus 3x, okay, and then that is divided by negative 3 again. Remember, we have to divide negative 3 into each of these terms, okay, the negative sign included. And last but not least, minus 9 over negative 3. So after we deal with the numbers, then we will end up with negative 6 divided by negative 3 gives us positive 2. We leave the exponent as is and move on. 3 divided by negative 3, that's going to give us negative 1. Okay? And leave the x as is, minus, and 9 divided by negative 3 is going to give us negative 3. And now we just have to make sure we dissolve all the brackets, treat the negative signs properly, and then we're done. We get 2x squared plus, well, since plus negative 1, that's the same as minus 1. But since it's just a 1 in front of my variable, I don't need to write the 1 at all. It's redundant. Okay, and minus a negative 3 is the same as adding 3. So here we go. 2x squared minus x plus 3. Okay, so we just have to be very careful with the negative signs. Just be careful with the negative signs. Okay, and down below we have a mixture of different forms altogether, so we just have to make sure we apply the right thing and get a little bit more practice. So here, example 3, we're going to multiply, divide by a polynomial, etc. You know what? I think this is also a great time for you to try all of them. So again, great time to pause the video. In this one, I'm not going to use my color codes because I'm just going to pretty much just do it, okay? All right. Doing my multiplication, I have -6 times this guy times this, and that, making sure I keep all of my signs. So that's going to be 2w squared, and then let's say minus -6, and then w. Don't forget, I keep only the w since I've taken care of the minus sign there. Okay, plus -6 in brackets times 5. Wow, that's a lot of space that I've taken up. Okay, so after that, actually I'll do each step in a different color. Then I take -6 times 2, that gives me -12. I keep the w squared. I get negative and -6, and there's no 1 or anything. The 1 is beside the w, but it's only a 1. So that just becomes negative, making it a positive 6w. Last but not least, plus, and then I have -6 times 5, that is -30, plus -30 is just the same as subtracting 30. And there you go. That's A. Next up, B. Okay, B, I'm going to have -10 over -2 plus 4w squared divided by -2 every time I'm dividing everything on the bottom. So then this is going to give me -10 divided by -2. This is going to be positive 5 because I have two negatives. And then I have plus, but wait, this is 4 divided by -2. That's going to give us -2 w squared. And to write this out a little bit better, this is 5 minus 2w squared, just dissolving those brackets. And technically speaking, if I have to reorder this polynomial properly, it will look like this because I want the w squared in front. I have to put -2w squared, and since there is no minus sign in front of the 5, that just becomes plus 5. Okay, so there you go. That is B. Next up is C. So again, the 2 is going to divide into each of these terms. So I'm going to get -6wg divided by 2 minus 16w over 2 minus 4g over 2. Okay, after I take the -6 divided by 2, I get -3, keep the w, keep the g, minus 16 divided by 2 is going to be 8, keep the w, minus 4 divided by 2 is going to be minus 2g. There you go. Okay, last but not least, wow, well, that's nothing fancy because I have my my constant in front, at the end, but multiplying order does not matter. So I can really just write it like this. If you really need to see it the same way as you've seen these questions before, that's essentially what it is. So if you ultimately want that, then again, -4 is going to multiply every single term on the inside. So that's going to look like -4 times 3m to the power of 2 minus -4 times 7, and which this is going to give us -4 times 3 is -12. Keep the m squared. Here, I'll write it in black. Okay, m squared. And I'm going to get -4 times 7, which is -28. But because I have a negative and negative, that's going to make it a positive 28. Okay, so there you go. Sometimes when you're writing this out, some people might prefer to write it this way, and that's okay as well. So -4, this is very normal. But some people might decide to, I have -7, so they go -7, and then they put in brackets -4. Okay, so yes, I'm still multiplying my 7 or -7 or -7 by -4. It's just that I decide to put it afterwards, and of course, order does not matter. And this might look a little bit nicer on the eye than what I have over here. Okay, so that's another option. Alright, so guess what? I'm going to end the video there because there's only so much variation we can do with these type of problems. The more variations that we can do is when we have to deal with monomials. So let's stay tuned for 3.5, section 3.5, where we have to multiply and divide polynomials by a monomial instead. But don't forget, fraction deal with fractions, so the numbers have to deal with the numbers. The constants have to multiply the coefficients or divide the coefficients. So that one we have to be very careful, okay? So I thank you for watching. I wish you the best of luck, and Fan Mama Physics signing out.